Okay, welcome back. Well, welcome back, everyone. Sorry, my chair drifted away. Welcome back, everyone, to another one of these videos where I talk about why a number is exciting. So, as you can see, I'm in a different setting than usual, which it's kind of throwing me off. My vibe is a bit thrown off. So hopefully these videos will still be good. Um, I've had some comments about people who say, it doesn't look like you really prepare these videos. Look at it. Look, I prepared. Look, I have 2 pages of notes, and this page of notes is on a test page printout. But yeah, I prepared. Okay. So I think what we're gonna try to do is, I have a blackboard here which has some research. So please don't look at the research. Don't steal my ideas. Not that they're any good, but so we're gonna start by doing the video part of the video on the blackboard because it's right here, right? So it's like, why would I not? And then at some point when my knees start to give up, I will switch to using the iPad. Which, in that case, maybe it's better. Maybe it's better. I'm gonna stop sharing screen. Okay. So, oh, he doesn't prepare. Okay. But then I don't know if you can see. Uh, okay. Multi-speaker view. No, wait. Uh, he doesn't prepare. Okay, I'm gonna pause the video. Just give me a second. Okay, I think it's working. Okay, so I'm gonna let's quickly erase this blackboard, this lavagna, as we say in Italian, or el pizarrón. I think it's that. Hopefully, I didn't say anything something stupid. I think it's that in Spanish. And then tableau, tableau, tableau noir in French. Um, this meeting is being recorded. Okay, good. Excellent. So, so today's video is about the number 27. Okay. By the way, oh, you can't see that. Um, whatever. I wrote 27 already. By the way, I'm using this chalk here. It's Hago Hago Hagoromo chalk, which is very good chalk. They don't sponsor these videos, but I wish that they did. So this this video is about the number 27, which you can't see on the screen, but that's what I wrote. Um, but we're actually going to take quite a long detour to get to the number 27. So to do this detour, we're going to go on a journey through what I will call the interval sum. So to the interval sum. Okay, we're going through the journey of the interval sum. So the interval sum is a name that I just gave to this thing. And what is an interval sum? So basically, suppose I have some number like 19. Okay. Then I'm going to define the interval sum of 19. So the interval sum of 19 as the sum from the first digit of this number to the second digit of this number, right? So it's the sum from 1 to 9 of the digits, right? So it's 1 plus 2 plus all the way to 9, okay? Which is, whatever it is, okay? Um, Now, okay, so we have integral sum. Why is this interesting? Well, you have different interval sums give you different numbers, of course. So like for instance, the interval sum of 13 will give you, I don't know, like 1 plus 2 plus 3. So it will give you 6, right? 6. Okay. Now, what about the interval sum of some other number? Uh, like 47. Oh, that's a good one. Okay. So interval sum of 47. Well, the interval sum of 47 is, 4 plus 5 plus 6 plus 7, which, 9, 15, 22. So that's 22. Okay, nice. So we have some numbers. We have some interval sums. Now, what is the point in what we're doing here? So let's just slightly abstract this concept, and let's just say I have a digit, like a number, a two-digit number, which could also be like 0, 5, right? So that I'm going to consider that as two digits. And let's just call that xy. Okay. So notice I put the xy in the entre guillemets, as we say in the French, just to ensure that no one thinks that I'm doing a multiplication. So I'm not multiplying x and y. Okay. Now I'm just saying it's x where x is from 0 to 9, and y where y is from 0 to 9. Okay, very good. Now, I have this xy, right? And then the interval sum, right, by definition, the interval sum of this abstract xy is, the sum from x to y, right, of I, right? So it's like, x plus x plus 1 plus x plus 2, dot, 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 all the way to, y minus 1 plus y. Okay, so hopefully, so far so good. Hopefully, the blackboard is not throwing anyone off. It's very nice chalk to write on. Okay, but as you can see, I'm quickly running out of blackboard. I cannot like scroll blackboard for the young viewers of this video. You can't scroll blackboards. They're physical objects. So, um, so I'm gonna switch to the iPad too. Don't worry if you're getting annoyed. Okay, but this is good because I can ask the question that I wanted to ask is, wouldn't it be cool, right, if, right, we could find a number, right? We could find a number where, so the question is, are there any numbers where the number xy, right? So like 19, 27, 45, whatever, like, 13, 47, whatever, that number itself was equal to its interval sum. That would be kind of cool, right? Like that would be kind of cool. So are there any numbers for which this is true? Right? Because then it's kind of cool. It's like, oh, how do you get the number that I just wrote down? But you could also just take the sum from, that first number that I wrote down to the last number. That's kind of cool. At least I'm kind of getting excited. Okay. So this is the question that I pose to my two viewers, which I probably know who you are. So this is the question. I'm gonna give you a second to think about it while I pause the video and switch to the iPad. Okay, I'm gonna pause the video. See, people say I don't prepare. Look at it. This is prepared. Kind of. Okay, pausing. Okay, so I'm back to sitting down on this chair. To be honest, this chair is not that comfortable. I ordered a chair from maybe I should go on this I ordered this chair from IKEA, and it's in my kitchen. Anyway, I feel like I digress. So this is the question that we have, right? Do we have numbers for which those numbers are equal to their interval sums? Okay. So, at a first glance, this question is well, at a first glance, this question is a great small exercise for computer science students in their first year, right? Because it's like, oh, I can maybe write a program that does this. But I'm not going to do this. This is not a video about writing a program, okay? Imagine for the sake of argument that we are now in ancient Rome, okay? We're in ancient Rome, and somehow we have iPads, okay? We're in ancient Rome, we have iPads, but we can't write computer programs, So the fact that this iPad works is pure magic, okay? So, we can't do this. We can't write a program. So then we kind of have to brute force this, okay? And that's kind of annoying, right? Because if I want to brute force this and I want to actually try to answer this question, then like how many candidates, right? How many candidates do I have? So the number of candidates here, is not insignificant for a human or for a Roman in Rome times, right? It's, from zero, remember, I'm counting 00 as a two-digit number. Mathematicians can write me a letter until until 99, right? So how many candidates do I have? I have 100. Whoops, I have 100 possible numbers, right? 100 candidates, right? Because from 0 to 99, that's 100 numbers. Okay, so that's quite a few, right? So what do I have to compute the interval sums of each of these numbers? That's kind of mendokse, as they say in the Japanese. What a drag, right? So we're not going to do that. We're going to try to be a bit clever. We're going to try to cut down on the number of sums that we need to compute. So first of all, there's one very easy way to uh, cut down on the number of numbers we have to consider is just by noticing that for the interval sum problem to be like valid, for a number to be sort of a valid candidate for the interval sum problem, then you know the number xy has to be such that x is less than or equal to y, right? So in my definition of interval sum, I'm not considering something like uh, interval sum of 76, right? Because what does it mean? Like I wanna only sum from smaller numbers to larger numbers, right? So I'm not taking like a generalization of the sum. If I had a sum that did something like this, then it's kind of like some might say, well, just do 7 plus 6. It's not super clear because eyes go from wait. Yeah, okay. So that's not a valid interval sum. I had to think about it a little bit. I paused the video without telling you, but if you have some like this, um, you can either say that it's kind of like there's no summand in sum. So you can define this as maybe 0, or you can just say that it's not defined. In either case, if it's 0 or if it's not defined, it's definitely like you're not going to have a 0 equal to something like 76, right? So we're not going to consider those numbers, which is great. That means that um, my list of candidates has decreased significantly. So why? Because if I sort of write down the list of candidates in kind of a shorthand, so I'm using this shorthand to mean like uh, the numbers where the first digit is 0 and the second digit is from 0 to 9, right? So this is really a shorthand for something like this, right? Okay. And I guess at this point I can drop the guillemot. Remember the guillemot here was to tell you that it's not a multiplication. But now that these are numbers, I think it's obvious that we're not multiplying. Well, hopefully it's obvious that we're not multiplying them. So I'm going to drop the guillemot just because otherwise it would waste a lot of virtual ink. Okay, so then we have from 1 as the first digit to 9. And I'm gonna write a few more of these just to give you the ideas or the idea. It's not more than one at this point. 8 and 9, and here this is just 9 and 9. Okay, so to prove to you that we've significantly reduced the number of candidates, let me just count them now, right? So remember now what's going on is I don't have something like 86 or 21 because that's just like an undefined or a interval a sum that equals 0, right? So those in either case that's not very useful for the purposes of answering this very cool exciting question. Right. So how many candidates do I have left? Let's see. So here I have from 0 to 9, so I have 10. Then here I have 9, then 8, then all the way to 1. So the number of candidates left is 1 plus 2 all the way to 10, which hopefully you remember this formula. So the summation of natural numbers up to n is n times n plus 1 over 2, which was famously discovered, at least this is what is told in the mathematical tales by Gauss, who The story, in case you've not heard the story, I'm perpetuating perhaps an untrue story, but I think this is a pretty cool story. Gauss, who who was a very brilliant mathematician, was given this problem as a sort of like uh, sort of homework for being naughty, because Gauss was like not paying attention, whatever, because he's like, oh, I'm the most brilliant mathematician, even though I'm just like 5 or 6 or whatever. So it was very young. I don't remember exactly what age. And the math teacher was like, "Hey, you are gonna sum all the numbers from 1 to 100." And then Gauss was like, "Okay, sure." And then Gauss went home, and his dad was like, "Oh, Gauss, you have to do this." And Gauss was like, "Yes, father, I will." And then he goes to his room. Presumably, Gauss had his own room, and he lit up his candle, because this is like when they had candles. And he looked at the problem, and he said, "I'm not actually going to do that. I'm just gonna do 100 times 101 divided by 2, and then I'm going to compute that, and then I'm going to tell the teacher that that's the sum." And he does that, right? And he goes to the teacher, and the teacher is flabbergasted. Is a very good use of that adjective here. And the teacher and he doesn't believe Gauss, because he's like, "Gauss, you are a naughty boy." And then so he does the sum himself. Like, he adds from 1 to 100. And this is like where there wasn't any computer programs, right? This is when they had candles for lamps. And so then you're like, okay. And then the teacher actually gets the same number. And then he's like, "Oh my God, Gauss, you brilliant naughty child." So in any case, the number of candidates here is 10 times 11 divided by 2. So 10 divided by 5 is 5. So I get 55 candidates. So I almost halved the number of candidates in 2, right? So I started with 100, now 55. But still, I don't want to compute the interval summands for each of these 55 candidates, because even the most interested viewers would not endure. So I'm going to notice a second thing. What is the second thing that I'm going to notice is, there's actually an upper bound on what the interval summand can be, right? So there's actually a max value for interval summands of numbers that look like XY, right? So the max value is basically summing all the possible numbers from 0 to 9, right? So the max value is going to be the interval summed of 0, 9, which is actually the same as the interval 1, 9, because 0 plus a number doesn't actually change it, but whatever. So 0, 9, so that's I from 0 to 9 of I, which, like I said, we don't need to sum the 0. Well, we sum the 0, but it just it's additive identity, so it just returns the sum without the 0. So from I1 to 9, and we are going to use again the formula from Gauss. Thank you, Gauss. So this is 9 times 9 plus 1, so 10 divided by 2, so 10 divided by 2 is 5, times 9 is 45. Okay, so 45, what is this? This is the max value, right? Max value of is of some number, right? So that means, right, by definition, or like, no, not by definition, but this implies that the interval sum of this can be at most 45. Okay. Well, that's kind of helpful, right? Because now, I had to first consider all of these guys and girls, right? These are the gender neutral, gender neutral. Well, guys, well, anyways, fuck. Oh, okay. Right. So there's these guys are from 0 all the way to 9. And now what I can do is I can cut out most of these, right? Well, not most, but I can cut out the ones that start with 9, 8, 7, all the way to 4, right? So I have 3 to 9, and then I have 4. And for 4, I'm only going to include 4 and 5, right? So 4 and 5. So now this is with the second sort of noticing. I've noticed the second thing. And what this tells me now is that I only have to consider candidates from 0. So I have to consider, these 10 candidates, then these 9 candidates, these 8 candidates, these 7 candidates, and these 2 candidates. Just for the sake of simplicity, I can already immediately see that, 44, the interval sum is 4. So that's not going to work. And 45, the interval sum is 4 plus 5, 9. So that's also not going to work, right? So let's just say that effectively the pool of candidates has been reduced to 10, 9, 8, 7. Sorry. So this is 8, 7. Okay, so that means that I have how many candidates left? Well, I have, so the number of candidates here is 7 plus 8 plus 9 plus 10. We could use Gauss's formula in some way, but I think I'm fairly confident that I can do this sum. 9 times 10 is 19, plus 8 is 27, plus 7 is 34. So we have 34 candidates left. Okay, nice. So we went from 100 candidates to, where did I say 100? Right, 100 candidates to 55 candidates to 34 candidates. Okay, pretty good, pretty good, pretty good. Now we're going to do the most interesting trick in cutting things down. So we're going to use something about the parity of the sums. So this is going to be notice number 3. So by notice, this is not like a notice of assessment in your tax returns. Don't worry about that. This is just the third notice. Okay. So what is the third notice going to be about? Well, here, let's just consider, for instance, the interval sum of 19. Okay. So what's going on in the interval sum of 19? I have 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way to 9. Okay. So now let me consider the parity. Okay. Let me consider the parity of this number. So whether this whole sum, right, if this whole sum is odd or even, right? That's what I'm going to try to see. Now, I could compute the sum, but I could also use this trick where, I know that I have an odd number. So let me just say it here. So if I have an odd number, right, and from an odd number, I add another odd number. So imagine like 3 plus 5. Then an odd number plus an odd number, so 3 plus 5 gives me an even number, right? So odd plus odd gives me even. Then odd, let's see, plus even. So if I have 3 and I have 4, then 3 plus 4 is 7. So that's going to give me an odd number. So I could prove this, but I'm not going to. And then, of course, summation is commutative. So if I have even plus odd, then it's also going to be odd. And then finally, if I have even plus even, then I'm going to get the number which is going to be even, right? Because 4 plus 6, that's 10, which is going to be even, right? So I'm going to use this fact to tell you what the parity of the interval sum of 19 is, right? So I start with an odd number, okay? Then I add to this odd number an even number, right? So that means that I go from being odd to odd plus even odd, right? So I remain odd. Okay. Then I'm adding this number 3, so this odd number to this odd number, right? So I add an odd number to an odd number, so I get an even number, right? Then so I'm here at this point, right? So and this is correct, right? 1 plus 2 plus 3, that's 6, which is even, right? So that's correct so far. Plus 4, right? So plus an even number. So plus 4. So plus an even number, which, 1 plus 2 plus 3 plus 4, that's 14. So this should be even, which it is, right? Because even plus even, our rule here is telling us that it's even, right? So this tells me that it's even. okay? Plus, plus an odd, right? So plus an odd, right? So at this point, I'm adding 5. So that's plus an odd. So I have odd, right? Then I have an odd number, right? So which also makes sense because at this point, I have 10 plus 15, so that is odd, right? Then at this point, I'm going to add an even number, right? So plus an even number. So odd plus even, that's going to stay uh, odd plus even, that's going to stay odd. Now, I could keep doing this, right? But what I want you to notice is that at this point, what actually has happened is I found a loop, right? Which is very nice, right? So I found a loop because notice from from this point here, it's going to be the same behavior because here I have, odd, even, odd, even, even, odd. But then at this point, right, this sort of behavior is the same here, right? So then it's just gonna, so if I unfold this here, it's just gonna be exactly the same as this thing here, right? So what that means is instead of like unrolling here, what I can say is from plus odd to this like so when I have even plus and odd, it's as if I'm restarting the cycle. So actually it's as if I'm just going back here. Okay. And now you're probably thinking like, why the heck is this useful? So let me show you, right? So I'm not actually going to finish computing the parity of the intervals of 1 to 9 here. I'm just going to write things down. So I'm going to write all of my candidates down at this point. So there's 34, so there's not that many. So if I was in ancient Rome, this would be a tolerable approach, I think. Hopefully, I would not be sent to the gladiators or to the Colosseum to face the gladiators. So I would be very scared facing a gladiator. So I'm just gonna write these down. So you can let me pause the video and then you can see what or like I'll pause the video and then I'll write them down and then yeah. Okay, so I've written things down and I've also written our odd, even cycle that we found over here. So now, why is this interesting? Let me quickly show you. I think this is kind of cool. So uh, let's just see what the parity of each of the interval sums is going to be. And to do this, I'm just going to have to use this cycle. Okay. So how is this possible? Well, you see that at 0, 0, so 0, 0, I'm just adding, 0, right? So 0 is even. So at this point, that means that I have an even interval sum, right? Then 0, 1, so the trick here is that I'm just adding plus 1. I'm adding the next consecutive number, but in the natural number line, I have evens and odds like intertwined, right? So the next number that I'm going to have is going to be an even number plus an odd number, right? But that's right here in the cycle, right? An even number plus an odd number. So that's going to be odd, right? So I'm going to have an odd number. And now I can just sort of basically mindlessly just follow the cycle. So I'm going to have 0 or odd, even, odd, odd, even, odd. Okay, nice. Okay. And now the other cool thing is, okay, I've done it for this one. Now, how do I do it for the second row? Well, here the second row, I'm starting with an odd number, right? And then I'm adding an even number, right? So that means that I'm in this part of the cycle. But really, that part of the cycle is just taking this guy, right, and moving it like that. Okay, so that's kind of cool. I think that's kind of cool. So that means, okay, I'm kind of excited. That means I can just do this. I can just do this and I can do this, and I can do this, and I can do this, and everything is good, right? And then again, right, I'm just going to shift things, right? I'm going to shift it. Well, actually, I'm not going to shift them. I'm just going to say, well, here, this guy is really starting at the same place as this guy. It's just that it's shorter, right? So that means that I'm just going to take this guy. Right? I'm going to take this guy. Yes. Oh, no. Oh, no. Oh, whoopsies. Oh, whoopsies. My apologies. My apologies. My apologies. My apologies. My apologies. Yeah, I talked to someone about these videos and he was like, yeah, you should really like do all of this ahead of time. And I was like, yeah, you're right. But in any case, this is what we get, right? And then again, what I can do for this next row is, it's just shifting it, right? So it's just I start here, right? And I move this here, right? So I have, these guys, I copy and I move them here. Okay, nice, nice, nice. And let's just double check, right? Oh, this is poorly shifted. Can we do better? Okay. And let's just double check. Let's just pick at random, I don't know, 14, right? So 14, is this going to be even? 1 plus 2 plus 3 plus 4, 3, 6, 10. Yes, that's good. What about 28? Oh boy, of course I picked them, people. 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So let's see, 5, 9, 14, 14, 6, 20, 27, 27, 8, 35, right? Which is odd, so that works out. Okay, very good. Very nice. Now at this point, you're thinking, okay, Ches or Chesray or whatever you're calling me. This is kind of nice, but why the hell? What the hell are we doing, man? Why do I care? Okay, so good question. Thanks for the question. Um, the reason why I care is because remember what I'm trying to do is I'm trying to look for interval sum of xy is equal to xy, right? So this like parity is actually an indicator, right? Because for the interval sum of xy to equal xy, the parity, of course, has to be the same, right? Because these have to be the same number. So if the interval sum is even, then it must mean that that number, right, is also even. And if the interval sum is odd, then that must mean that that actual number xy is also odd. Okay. So then what we can do is we can check if this rule, like how we computed the expected parity, is the same as the parity of the number, which is fairly easy to do. Ancient Romans and ancient Greeks could do this, right? This is fair game. Okay. So, so, okay. So let's just see if like the parity of this actual number is the same as the parity of the interval sum, right? So the thing in red. Okay. So here the parity of 0 is even, and the expected parity of the interval sum is also even. So that's good, right? What about 0, 1? Well, 0, 1, that's odd, and the expected parity here is odd. So that's also good. 0, 2. 2 is even, right? 2 is even, but the expected parity is odd, right? Because it's going to be 0, 1, 2. So that's 3. So the parity of that is odd, but the parity of 2 is even. So there's a mismatch. So I can remove it from the candidates, right? And remember, I'm doing this without actually computing the numbers. Here I'm just telling you like just to justify. But what I've done so far is I haven't computed any interval sums. Okay. So that's why this is kind of cool. Okay. So let's just keep doing this. And at some point, once you get it, I'm just going to pause the video and I'm going to do the rest. Okay. So, even, but this is odd. So this is no good. Even, and this is even. So this is good. Odd, and this is odd. So this is good. Odd, but this is even. This is no good. Even, odd, no good. Even, odd. Odd, good. Odd, good. Odd, even, no good. Okay, I think you get it. So now try to see if you can fill out the rest of the page, and I'll see you back in a half. Okay, so I filled things out, and what I actually want to point out is this nice pattern, which results from this initial cyclical pattern, which is, the check marks, right, are kind of like, yes, yes, no, no, yes, yes, no, no, yes, yes. And then they're shifted down one in the same way that I shifted the cycle by one, right? So now they're like this, right? They're sort of paralleled. Oh, that means I made a mistake here. Oh, nice. Okay. So that helps me catch mistakes. Right. So they're parallel here, right? So I have yes, no, no, yes, yes, no, no, yes, yes. Okay. And then again, I'm going to have, so here I'm sort of restarting at this point. Yes, yes, no, no, yes, yes, no, no. And then I just parallel it here. So yes, no, no, yes, yes, no, no. right? Nice. Okay, very nice. Hopefully you think this is nice. Now, what does this mean? Well, I just have to collect right now. I just have to collect all the ones with the positive check marks, which let me just write them down at this point. So that's going to be 0, 0, 0, 1. So, hopefully the ancient Romans had enough paper to do this. 0, 5, 0, 8, 0, 9. Let's see, 11. I'm going to pause the video even for this. Okay, I've unpaused the video. So now look at this. This is our candidate list, right? So after this noticing this third cyclical pattern, we've reduced the number of candidates from let's see, we had 34 at this point, and now we're at 3 times 6, so 18. Wow, 18 candidates. So we've almost halved it again. Okay. And now at this point, I'm kind of running out of tricks. That's why this page is kind of fairly simple. So at this point, what we can do, if we kind of still don't want to compute sums, we can just see. So this isn't really a math trick. This is more like a cognitive sort of trick where I think humans can probably recognize fairly quickly that something is going to be larger than its sort of allowed range. Okay, so the fourth trick. So notice number 4. Remember, this is not a notice of assessment as produced by Revenu Quebec or the Canadian Revenue Agency. Is just use your brain. Use your brain. Okay, so what do I mean by that? So are there any numbers whose interval sum is obviously too big to fit in that like digit range or too small to fit in that digit range? Well, 0, 4, that's 1 plus 2 plus 3 plus 4, right? So that's 10. So that's already outside of the range 0 to 9, which means that all these 4 guys are no good. They are no bueno. So these are no bueno. Okay. Now let's see. 11, that's clearly too small, right? Because that's just 1. 14, 15, that's maybe plausible. 18, 19, well, 18 and 19, 19 I know is the max, so I know that's 45. And 18 is one less than the max, so 45 minus 8, so 37. So those are obviously these interval sums are too big for the range. 22, 23, these are again too small because that's only 2 and 5. So those are 26, 27, that's plausible, right? 33, again, too small. And then 36, 37, again, plausible, right? So actually, the list of plausible candidates based on like a quick heuristic search is going to be, so the final list of candidates is going to be 0, 0, 0, 1, let's see, 14, 15, 26, 27. So it's, the bon augure, as we say in French, that 27 is there, right? Given that this video is about 27. 36 and 37. So now at this point, I kind of do have to compute interval sums. So sorry about that, but you got to do some work at some point. So the interval sum of 0, that's 0. The interval sum of 1, that's 1. The interval sum of 14, well, that's 1 plus 2 plus 3 plus 4, that's 10. The interval sum of 15, that's plus 5 to the interval sum of 14, so that's 15. The interval sum of 26, 2 plus 3 plus 4 plus 5 plus 6, that's 5, 9, 14, 20. Of 27, that is indeed just adding a plus 7 here, so that's 27. The one for 36, that's 3 plus 4 plus 5 plus 6 plus 7. So that's, let's see, 7, 12, 18, 25. Wait, what? No. Sorry. Désolé. 7, 5, 12, 18, right? Plus 7, then that's 25, right? So remember what we were looking for? We were looking for interval sums of numbers give you that number, right? Well, it looks like we have 4 winners, right? we have, the interval sum of 0 is 0. The interval sum of 1 is 1. The interval sum of 15 is 15. And of course, what do you know? Amazing. The interval sum of 27 is 27. And, of course, 0, 1, 15 are also there, so it's not like unique. But, 0 and 1, those are like constants, so they're, basically they don't really count. And then 15, honestly, I was kind of annoyed when I saw the 15 was there. I really thought 27 was the unique one. Um, but 27 is the unique number that starts with a 2. And that is a perfect cube. 27 is a perfect cube. So that's kind of nice. And finally, to close off this video, if you don't believe what I just did, right? If you're like, I don't believe this Cesare guy. I took the liberty. Now I know the most of the motivation of this video was, ancient Rome. It's not going to happen. But suppose the ancient Romans had access to a Dell laptop and to the Python programming language, in particular the Python 3. Wait, I'm not sure. Am I sharing my screen? I think I am. You are screen sharing. Okay. Then, you could write a kind of program like this, which I did not use ChatGPT to write this. It's sort of like you can notice I turned Copilot off because it was like, this is really annoying. I just wanna think by myself. Okay. Sometimes that's what you want to do. Okay. Man, this video is really long. Um, and if you do this and you check the correctness, then lo and behold, you get 0, 1, 15, 27. So you know that what I did was not completely crazy. So thanks a lot, everyone. Thanks for watching this video. 27 is a real cool number. I think it's the coolest number that is 27. What? Some final remarks. Make sure to thank people that say that 27 is cool, and make sure to thank Gauss for his formula, and make sure to be grateful that we no longer have to fight gladiators as a consequence of not getting a proof right. Okay, thanks a lot, everyone. See you next time.